Hello everyone, myself Purva Joshi, Assistant Professor at LJ Institute of Engineering and Technology. Today we are going to solve few examples of limit and continuity. Okay, so let's first begin with the definition of a limit. So if f of xy is a function of two variables x and y, then limit xy tends to ab f of xy equals to L. If and only if for any epsilon greater than 0, however small we are taking, there exists a delta greater than 0 such that mod of f of x comma y minus L is less than epsilon whenever mod x comma y minus ab this is less than delta for all values of xy. Okay, this definition we have already studied. Okay, now let's study few points. So if limit xy tends to ab f of xy equals to L, where L is unique, then we can say that limit exists. Okay, so if we get a unique answer L, then we can say that the limit exists. Okay, now to check that the limit is exist or not, what we have to do, we have to use this formula. Means firstly we will apply limit y tends to be f of x and then we will apply the limit of x, and next we will apply the limit of x first and then we will apply the limit of y. Okay, and both the limits should be equal, then we can say that the limit exists. Now if this point number 2, if this holds for ab equals to 0 0, then we have to check further whether the limit depends on the path y is equals to mx raised to n or not, right? So if you get same answer for ab equals to 0 0 for this two limit, then we will check for y is equals to mx. Okay, then we'll check for y is equals to mx square. If all the answers are same, then we can say that limit exists. And if we have the limit depends on n, okay, then we can say that limit does not exist. Okay, now let's begin with the example. Determine whether the limit of this function f of xy equals to x square y upon x raised to 4 plus y square exists at the point 0, 0 or not. Okay, so firstly we will start with this path 1. Okay, here what we will do, firstly we will apply the limit of x and then we will apply limit of y, right? So we will choose this path and the function is given, that is x square y upon x raised to 4 plus y square, right? So in place of x, firstly we have to substitute 0. So if you will substitute 0 over here, so you will get answer 0. Okay. Next we will apply the path 2. So for that what we will do? Firstly we will apply the limit of y. Okay. And then we will apply the limit of x. And the function is given, that is x square y upon x raised to 4 plus y square, right? Now firstly in place of y substitute 0 over here, so you will get answer 0. Okay, now we have ab as 0 0 and we have the same answer for this path 1 and path 2. So we will write y is equals to mx. Okay, now function fxy is given in the question, that is x square y upon x raised to 4, x square y upon x raised to 4 plus y square. Okay, this is the question given. Now we will take y is equals to mx in this function, so you will get only limit of x because y we are writing in the form of x. Okay, so limit x tends to 0. Now x square into mx upon x raised to 4 plus m square x square, correct? In place of y just write down mx, right? Simplify this, so you will get limit x tends to 0 x cube m upon, now take out x square common from the denominator. Okay, so here you will get x square plus m square, right? This x square will get cancelled and here one x will remain. Now if you will apply the limit, so this term will goes to 0. Okay, now we have to check for the path y is equals to mx square. Okay, so in place of y, now we will substitute mx square, so you will get limit x tends to 0, x square into, now in place of y, mx square. Okay, and upon x raised to 4 plus, now we have to write y square, right? So it will become m square x raised to 4. Okay, simplify this, so you will get limit x tends to 0, mx raised to 4, and in denominator take x raised to 4 common. So we have 1 plus m square. Okay, this x raised to 4 will get cancelled. So what remains is limit x tends to 0, m upon 1 plus m square. Okay, now m can be any value. So if you will take the different values of m, you will get different answer, right? So what we can say that this limit depends on m, right? Therefore, we can say that limit does not exist. Okay, so in this way we have to check whether the limit exists or not. Okay, so for example, if you get 0 answer over here, so we have all the answers same, right? So you can say that the limit exists, but here we have the limit which depends on m, therefore limit does not exist. Okay, now let's discuss the next topic, that is continuity of any function at point AB. Okay, so firstly we will study its definition. A function fxy is called continuous at AB if first point f of AB exists. Means this function should be defined at this particular point AB. Okay, next point is limit exists. Means this limit xy tends to AB f of xy equals to L, and this L should be a unique number, right? And the third point is limit xy tends to AB f of xy is equals to f of AB. Okay, so if these 3 points are satisfied, then we can say that the function is continuous at this particular point. Okay, so now let's begin with the example. Show that f of xy equals to 3x square y upon x square plus y square for xy not equal to 0, 0 and 0 for xy equal to 0, 0 is continuous at origin or not. Okay, so first step is what we have to see that f at 0, 0 exists or not. Okay, so now f of 0, 0 is given 0 over here in the question, right? So it exists. Now the second point is to find the limit. So for that what we have to do, we have to apply the path. So firstly we'll write the path 1. So limit, firstly we will apply the x limit and then y limit, right? The function is given, that is 3x square y upon x square plus y square, correct? Now first in place of x just write down 0, so this numerator is 0, therefore this whole term is 0. Okay, now we have to apply the path 2. So for that what you will do, firstly we will apply the limit of y and then limit of x. Okay, and the function is 3x square y upon x square plus y square, right? Now in place of y substitute 0, so this numerator is 0, therefore this whole term is 0, correct? Now next step is to apply the path 3, means we have to write y is equals to mx in place of y. Okay, and the function fxy is given, that is 3x square y upon x square plus y square, right? Now we will apply the limit, so you will get limit x tends to 0. Now y is equals to mx, right? So in place of y just write down mx upon x square plus in place of y mx, so we will get m square x square. Simplify this, so you will get limit x tends to 0, 3x cube m upon, take x square common from the denominator, so you will get 1 plus m square. Okay, this x square will get cancelled, 1x will remain over here, right? Now in place of x substitute 0, so this answer will go to 0. Okay, now we will apply the path 4, that is y is equals to mx square. Okay, so limit x tends to 0, 3x square into mx square. okay, and upon x square plus here you will get m square x raised to 4, okay. Simplify this, so you will get limit x tends to 0, 3x raised to 4 m upon, take out x square common from the denominator, so you will get 1 plus m square x square, okay. This x square will get cancelled over here and we will get x square over here, right. Now if you will substitute x equals to 0, this numerator will be 0, okay. So what we can say that this limit exists because we have the same answer, that is 0. Now the third step is to see that this limit xy tends to 0 comma 0. Here we have 0 0, right? This f of xy is equals to what? 0, and this is same as f of 0 comma 0, right? So from this we can say that this function is continuous at origin, right? So I hope you have understood throughout the session. Thank you for watching.